Hello everyone, and thank you for joining us. We are Team FintechBois, and I am Minh Phan, along with Lâm Đỗ, Sang Phạm, and Minh Hoàng. We are excited to deliver these presentations as part of the RMIT GenAI and Cybersecurity Hackathon 2024. Today, we are discussing the strategies for improving accuracy or optimizing in natural language processing, or NLP. NLP has made impressive strides in recent years, but optimizing models to handle diverse, complex tasks requires sophisticated methods. In these presentations, we will break down three core strategies to enhance NLP accuracy: prompt engineering, fine-tuning, and retrieval augmented generation. We also discuss the unique challenges these strategies bring and explore the future implications. So, what is optimizing NLP? Optimizing NLP isn't a linear journey. Think of it like having two primary axes of control. One is the context optimizations, ensuring the models have all the relevant informations, and the other is behavioral optimizations, where we specify exactly how the model should respond. Different tasks demand different balances of the two, and the approach we take, whether prompt engineering, retrieval, augmented generation, or fine-tuning, depends on which axis we need to optimize. So let's explore each strategies in a more technical detail. First, let's dive into prompt engineering. This technique involves crafting prompts that guide the model's behavior without altering its underlying parameters. Through specific phrasing, structure, and example-based prompt, we can significantly influence how the model interprets text. Prompt engineering lets us tap into the model later knowledge, essentially instructing it on what output we are aiming for. One effective structure for prompts consists of three parts: instructions, context, and questions. For instance, if we are designing a prompt for sentiment analysis, the instructions might be identify the sentiment of this review, followed by the context of the form of the actual review. And then questions or call to actions. What is a sentiment? The image on this slide demonstrates a specific technique within prompt engineering called field shot prompting. In this method, we provide the model with several examples of the desired task to guide response style and accuracy. For instance, when training the model to classify the product reviews as positive or negative, we include a few sample reviews and their correct labels. In this example, the prompt might include entries like great product, 10 out of 10, and positive, and another entries like didn't work very well, negative. By showing this example, we establish a pattern for the model, allowing it to predict the sentiment for new reviews more accurately. A research supports this approach, showing that well-crafted prompts can improve task performance and reduce the need for more resource-intensive model retraining. However, prompt engineering has limitations, especially when scaling. Its change in the prompt structure can affect the model's response unpredictably, so it works best in the cases where rapid experimentations and real-time adjustment are possible. So that's all from prompt engineering, and moving on to fine-tuning, presented by Lâm Đỗ.
Okay, thank you, Minh Phan. My name is Lum, and I will be presenting our second strategy, which is fine-tuning. Okay, so fine-tuning is continuing the training process on a smaller domain-specific dataset to optimize a model for a specific task. So this process will help the NLP models to learn domain language patterns, terminologies, and textual chat nuance, making it more proficient in handling specialized queries. And this technique has been researched and applied in both academic and industry fields. The effectiveness of this technique is backed by a study by Simon Friedrich in 2017, showed that fine-tuning can significantly increase the model accuracy and relevance for niche applications without overfitting. And a key example of fine-tuning in the industry is BERT, designed to enhance natural language understanding. So fine-tune across multiple language, BERT accurately process the diverse linguistic context and transform it into a multilingual tool, and that improve the search engine capability. So what are the steps to fine-tune the model? First, you need to collect data and prepare domain-specific data, which are removed of the noise, errors, and irrelevant content. And then, when you have a list of desired model and want to fine-tune it to maximize the accuracy by selecting the best combinations of hyperparameters value. In these steps, research and randomized search can be utilized with the ability to use cross-validations to evaluate the different combinations of hyperparameters value. In addition, a powerful technique can be employed, which are the example method, which can combine the model that perform the best. And this example method can do better accuracy than any single model, and it will reduce individual errors. And throughout this step, we can significantly enhance the chatbot performance and accuracy, leading to a better user experience and a strong community engagement. Okay, so that is the end of my part, and next up will be Sam.
Thanks, Lam. And another strategy is RG. RG stands for Retrieval Augmented Generation. That's combined two systems: an external retrieval model that searches a knowledge base and an internal generation model that integrates the retrieved information into the responses. RAG is valuable for tasks that require up-to-date information or extensive factual accuracy, as it allows the model to query real-time information instead of relying solely on its internal weights. So RNG operate by first querying a knowledge base, retrieving the most relevant documents, and then conditioning the language model to generate a response based on its information. So for instance, in the industrial application OpenAI's Codex, where RNG retrieves programming knowledge from code repository to improve the coding query accuracy. So from the academic research, Lewis stated that how RNG outperforms standalone language model on knowledge-intensive tasks, bridging the gap between stored knowledge and dynamically retrieved content. RNG architecture requires efficiency, retrieval algorithm, and high-quality knowledge databases. And move on, Min will represent about the challenges.
Okay, so thank you, Sang, for your sharing. So my name is Nidman, and I will be presenting about our challenges and our future impact. So while these strategies bring clear improvement, each come with a distinct challenge, and the most notable two are the demanding data quality and the computational cost. So retrieval augmented generation requires a well-maintained bias-free knowledge base, and this is to avoid inaccuracies or unintended bias. And one of the major issues regarding data quality is the difficulty in acquiring balanced and unbiased data. The large language models, as we know nowadays, mostly use common graph. However, the large data set on the internet is not always as diverse as we perceive it. According to certain research, there is a clear gender and age imbalance in the two most used platforms for scrolling data, the Reddit and the Wikipedia. And these bias or low quality data can lead to many drawbacks, like the encoding of stereotypes or the intersectional bias. And this will hinder the model from producing the desired output. So another challenge is the computational cost, and particularly with the fine-tuning and the RG, which both demand significant resources. A study has also shown that on increase of 0.1 in VLAU score, which is to measure accuracy, for a translation model from English to German, the organization has to fund 150,000 US dollars. And for small organizations, the resource can limit access and create a divide in NLP development. And as we look into the future, this optimization technique will likely have to democratize access to NLP by making it easier for small companies and institutions of all sizes implement high-performing models. RAG and prompt engineering, for example, can open new opportunities for companies with limited computational resources and allow them to optimize without high retraining costs. And we can expect these strategies to make NLP more accurate and more versatile to be applied into fields like healthcare, law, and education, where accurate language processing is critical. So to sum it up, we have covered three essential strategies from engineering, fine-tuning, and retrieval augmented generations. And these are transforming the field of NLP. So each offers unique methods for optimizing model performance with specific benefits and challenges. And by leveraging these strategies, we can drive NLP systems toward higher accuracy and reliability, making them more adaptable to the demands of the real-world task. So thank you for your attention, and we look forward to any questions you may have.